everyone, and welcome to the AirMiners conference panel on the economics and social science of carbon removal. So we've assembled this panel to discuss the economics, law, social acceptability, and technological viability of different carbon removal pathways so that we can all collectively as a community move toward an understanding of the kinds of things that need to be done so we can get from where we are now to where we need to be in terms of deployment and scaling. So just like in the past panels, please write your questions down as you'll have the ability to share video and audio to talk with the panel in about 30 minutes after our main discussion. You can also feel free to leave questions in the event chat as well. So, or not the event chat, in the panel session chat. So if you look on the right, it should say panel session, then you hit chat. So that's the chat specific to our panel. You can put questions in there as well. We're going to prioritize people who want to join the panel and actually talk with the panelists. But if there's time or some space in between, we may also address some questions in the chat as well. So just as a quick introduction of myself, my name is Grant Faber. I am a techno-economic assessment researcher at the University of Michigan Global CO2 Initiative, and I will be the moderator for our panel today. And so I'm going to go through some introductions. So first, Romany M. Webb. We're very fortunate to have her joining us. She's an associate research scholar at Columbia Law School and a senior fellow at the Sabin Center for Climate Change Law. She's also the program's vice chair of the Climate Change, Sustainable Development, and Ecosystems Committee of the American Bar Association. We also have with us today Sabine. Sabine leads the Working Group on Sustainable Resource Management and Global Change at the Mercator Research Institute on Global Commons and Climate Change, and she is also a professor of geography at Humboldt University in Berlin. She was also one of the authors on the IPCC special report on global warming of 1.5 degrees Celsius. And Evan, my possibly long-lost cousin or brother, both with beards and these plaid blue shirts here. So Evan Sherwin is a postdoctoral scholar in energy and resources engineering at Stanford University, where he works on integrating data science and energy system models to inform decarbonization policies. He holds a PhD in engineering and public policy from Carnegie Mellon University, where he did his dissertation on decision-making about energy systems in the face of uncertainties. But clearly we have this panel of geniuses and of experts who will hopefully share some of their brains so that we can incorporate into our brains. And so the first question I want to ask, as you know, in AirMiners and in the room today, we have a lot of entrepreneurs, scientists, students, people trying to, they really want to make a difference. You know, they really want to help scale and deploy these technologies. So what are some of the highest leverage things that these types of people can do to help reduce costs, to break down the barriers to scaling and to deploying carbon removal technologies? And so I'm just going to throw that out there, and anyone can take it up, and hopefully we can discuss.
That's a very broad question, and I think the answer is quite different depending on who's listening. So from much of my focus is on figuring out priorities for research, development, and deployment. So for companies, for engineers who are trying to think through where should they be focusing on their particular, what technology should they be focusing on, what parameters should they be working on. This is an area I've been working on through a combination of techno-economic assessment and optimization. How deep do you want me to go right now, or should I stay shallow for now?
You can stay shallow, and then we'll go around, and then maybe we can all dive a little more into the question after the first round.
Absolutely. So I think fundamentally we're going to probably, depending on the general policy strategy we end up taking, we're probably going to want to be both deploying some of the existing, a number of the existing direct air capture technologies that we have at pretty large scales, carbon dioxide removal approaches, while simultaneously developing the next generation of technologies. And I think one of the biggest things that I would like to see us continuing to work on is systems level analysis of what will it look like for us to be deploying the systems at scale? How are they going to be integrated with the rest of the energy system? So that's I'm a researcher and a modeler, so I kind of have a modeling bias. I'm not saying everybody should go do modeling, but I think that these large scale questions of how do we integrate direct air capture into a rapidly decarbonizing energy system are some of the most interesting.
Yeah, I guess I'll jump in. I think Evan's right that the answer to this question really depends on sort of your background, where you're coming from and who you're speaking to. I agree that sort of a broad perspective is needed. I think it's really important that scientists and researchers and entrepreneurs look beyond just the technology and at a broader range of sort of what I would class as enabling conditions that are required to actually get them in operation in the real world. And so I'm a lawyer, and so I tend to think about issues like what is legally permissible? Do you need permits? How difficult are they to get? Can you sort of can you go through the permitting process in a time and with a cost that's kind of reasonable and consistent with making these things commercial? But there's also a bunch of other issues like social acceptability issues. Are these techniques going to be opposed by particular communities or particular stakeholders? How do we sort of manage and mitigate that level of opposition? And I think it's really important to consider those sorts of broader issues upfront as we're developing the technology. Because, if we're thinking about a specific project in a specific location, that has legal implications, has social implications, has other implications that if we can get a handle on them at the start before we sort of move too far down the project path, then we can really manage and mitigate any issues that could arise and make the whole process much smoother, much more cost effective, and just much easier to get these technologies actually into the real world.
And then let me round off. First of all, I agree with the previous speakers, but maybe I can give a little bit the economics perspective at the end, because what I'm actually seeing out there is a lot of motivation, and people are actually doing a lot of things to identify leverage points and act upon them. Right? They're looking at niche markets, symbiotic relationships in industry, and all sorts of things, business opportunities, voluntary carbon markets, working with offsets and what have you, right? But I think we shouldn't forget that in the end, and warranting all this motivation and good things that are actually already going on, removing CO2 is actually a sort of service that you provide to society. It's something that in the end needs to be compensated for, because you're sort of providing a public good, even if you manage to also find a business opportunity. So without proper policy frameworks, I think it would be difficult to achieve the scales that we actually see in the kind of scenarios that lead us to reach the Paris goals.
So thank you all for those. So in those answers, policy and law both came up multiple times. Can the panel talk about and kind of speak to what are some huge policy and legal barriers facing the deployment of carbon removal technologies? And then what can we as individuals, how can we think about addressing those?
I can speak to the legal piece, and I'll leave it to others to speak to the policy piece. It's a really good question. It's actually really hard to answer from a legal perspective, because the legal framework for these different approaches depends on exactly what your approach you're using and exactly where you're using it. But generally speaking, the legal framework is highly complex. In many cases, we're dealing with both international and domestic laws. At the domestic level, in a country like the US, you're dealing with federal, state, and potentially local laws. So you end up with this kind of layering of laws that can be very difficult, costly, and time-consuming to sort of navigate. Adding to those issues, for most of these CDR and carbon storage techniques, there's no sort of specific dedicated legal framework. And so these projects end up being subject to more general environmental laws that were developed, frankly, to deal with other sorts of activities and are, in many cases, very poorly suited to the types of activities we're talking about. So just to give one example, I'm involved in a couple of projects that are looking at the possibility of storing carbon dioxide in subseabed rock formations. And there's some suitable sites off the coast of the United States in areas underlying US waters on what's called the US Outer Continental Shelf. In order to store carbon in those areas, you would need a lease from the federal government. And there is a leasing framework in place, but that leasing framework was set up to facilitate offshore energy development. And so we're trying to fit carbon storage into this legal framework that was set up to facilitate energy development. And so as a result of that, there's all these sort of strange requirements that you have to meet that don't make sense in the carbon storage context. So the way that plays out in the offshore carbon storage context is that you can get a lease to store in the subsea bed carbon dioxide that's captured at a coal-fired power plant, but you can't get a lease to store any other sort of carbon dioxide. So you have these sort of, because we're dealing with these general frameworks, you have these sort of legal hurdles that don't need to be there, don't make any sort of rational sense, but that we're just kind of in this situation with a legal framework that just doesn't work for these sorts of activities. So it's really a situation where I think the law needs to catch up with the science and the technological development here.
Maybe I can jump in on policy, because as I was saying before, carbon removal companies will be sort of providing a kind of a public good by removing some of the CO2 that we are still about to emit into the atmosphere, even though our carbon budget is almost being used up if we want to reach very ambitious targets. So that would mean that you would get compensated by a CO2 price eventually. But for this, of course, there are a lot of bottlenecks still. First of all, of course, you would need to have a very good system for monitoring and verifying the CO2 removal. And while that might look more straightforward for capturing CO2 at some point source and then storing it geologically, a lot of the land-based options are definitely more tricky in that respect. But of course, you would need to be able to measure things so that you can compensate for them. Also, you would need a kind of governance architecture to govern all the other aspects, non-carbon aspects. There might be other side effects of a socio-economic nature that you would want to govern as well. So that needs to be in place as well. So while carbon pricing is something that is maybe not a surprise to come from an economist, I also do see, if I compare the IPCC scenarios with what we actually see in the real world, that we have a large innovation gap, and that in the short run, medium run, we might need to do different things in order to accelerate innovation and catch up, maybe support pilots, demonstration, and do something to sort of help these things to get off.
Absolutely. I agree very much with the points you both made. I think that the legal issues for sequestration are going to be a lot more difficult than the legal issues with the capture. But I think fundamentally, when we're talking about the most important policy questions related to carbon dioxide removal, it's the question of, well, what is the incentive to do carbon dioxide removal? Because fundamentally, in the absence of, as Sabine said, in the absence of some sort of pricing on carbon, and that could be a carbon price, that could be policies that penalize the use of carbon dioxide, which in economist terms sort of translates into a price, then really the only incentive for carbon dioxide removal will be these sort of environmental, social, and governance pressures within companies from investors, which it's promising to see companies like Stripe and others making these pledges to do negative emissions. But fundamentally, it seems to me that the impetus for further development of carbon dioxide removal really has to be policy driven. I think that in the absence of either firm commitments of governments or other emitting entities, as has been brought up in the chat, there's going to be, that's a way that we can get firm incentives for development of these technologies.
May I also say that there's actually a lot of really good discussion going on in the chat, also pointing to the kind of policy uncertainty and how this is like further undermining. So this is, of course, also something, as long as politicians can't credibly commit to at least some sort of minimum carbon price, that will, of course, also undermine incentives for investors. So there needs to be a strong signal in the form of such an of such a carbon price that could be sort of guaranteed. I totally agree. So it's just I was a little bit sidetracked reading all the good comments that came in.
So yeah, so now that we're on this point of talking about policy, talking about public investments, maybe public funding of R&D, maybe government procurement, I don't think that explicitly came up, but it could be part of a strategy to support carbon utilizing, carbon removing products. On that point, I'm curious how we can think about opportunity costs of our investments into multiple pathways. So what I'm envisioning here is, you know, we have the government, but also say investors, philanthropic organizations, wealthy individuals, whoever. How should they really go about deciding, well, I want to put my money into carbon removal, or should I put it into further research on better solar modules or something like that in some sort of other mitigation pathway? Or should I put it into wind turbine permitting, expediting, or anything like that? How should investors, people who are trying to allocate funds to support defossilization, decarbonization, carbon removal, how should we think about our opportunity costs of those investments?
Well, maybe I can go first, because I think this is sometimes a little bit entangled in the discussion. And I think it's important to stress that it's not an either or. I think we need all we can do in terms of mitigation, and then what we actually see in the very ambitious climate stabilization scenarios is, on top of that, we still need to remove some of the CO2 that we're still putting out in the atmosphere. So I think that is definitely, I mean, even if we go about it with common sense, it should be clear that it's always a better idea to not mess something up in the first place rather than cleaning it up afterwards. So having said that, though, we can't wait too long to find out that in the end we won't be able to reduce emissions quickly enough by the time we need to reduce them to zero. So most of those scenarios show us that we will have substantial residual emissions, and that's also something that we need to be prepared for. So I think a sensible approach is really a portfolio approach where you sort of be prepared for the very likely situation that we will have to clean up quite a bit of the CO2 that we're still emitting in the middle of the century, but still not lose the focus on mitigation and the need to actually make our lives less carbon intensive.
So here's how I look at this question, because as I see it, the question really is, how much should we be willing to accept as a price for carbon dioxide removal? Should we be targeting technologies that are maybe $300 a ton of carbon dioxide removed? Do we think we can get lower than that? And I think the way that we determine that is through, again, a macro energy systems approach of really looking at, as Sabine said, if we try to net zero the entire energy system, in a lot of cases, there will be way cheaper ways to do that than with carbon dioxide removal. Renewable electricity, thankfully, has come down so much in cost. It's pushing a lot of fossil fuels off the grid. But in some cases, we're going to be left with some pretty expensive things to decarbonize, and that will be both applications like aviation, where we right now really need liquid, basically hydrocarbon fuels, unless we want to replace the whole fleet of airplanes with a new technology, which is, and there's promising developments in things like electric airplanes or hydrogen, but even if those come into place, we're probably going to want to continue to have hydrocarbon fuels for aviation. So then this becomes a question of, well, how much does it cost to produce net zero alternatives for that application, or to produce really zero alternatives, like hard zero alternatives. And if those are higher than the cost of air capture in some of those cases, well, then that tells us, well, okay, if air capture costs X amount, and it would cost, in terms of an implicit carbon mitigation cost to reduce emissions, something higher than that, that tells us we should be willing to pay, whatever that is for carbon dioxide removal. And if we're not there yet, it makes sense to target technologies that can get down to whatever that level is. So yeah, I think it really does make sense for us. Right now, there's so much uncertainty about what carbon dioxide removal is going to cost in the long term. There are kind of whispers about what Climeworks current projects cost. Maybe they've released some more cost information. I was too nervous to ask that directly to my co-panelists last panel. And we've seen techno-economic analyses coming out of various companies, including Carbon Engineering. But of course, we've seen techno-economic analyses for many technologies that ended up being a little more optimistic, or sometimes much more optimistic than what ended up actually happening. So I really think that's that larger scale approach of what are we targeting, what technologies do we think conceivably could get us to whatever level we're targeting or lower, should be a criterion we use for figuring out where we invest our research and development and deployment dollars here.
Yeah, I think, I have quite a different perspective on these issues, I think, because I'm not an economist. I think the approach that you both have laid out is, very rational, but, and makes theoretically good sense. But, in the real world, when we're thinking about governments acting on this and making policy decisions, tends not to be quite so rational in many cases. So I think that there's kind of opportunities to broaden the lens here when we're looking at and comparing different options. So again, going back to what I said before, that we need to take this sort of more holistic view of what's actually required to get these things deployed in the real world, and how feasible that is. I think we should be looking at things like not just sort of technical feasibility and economic feasibility, but also like social acceptability and feasibility, legal acceptability and feasibility. Also, I think that we should really be thinking about sort of co-benefits and risks of these different technologies, because, those are important by themselves, but they also play into those broader sort of feasibility and acceptability questions. So, there's some approach, like a enhanced weathering type approach, an ex situ mineralization type approach that would not only capture carbon potentially, but could have big benefits for agricultural productivity if you did it on agricultural lands potentially. Things like ocean-based, Evans gringing, but things like ocean-based approaches, seaweed cultivation, other ocean-based approaches that could have co-benefits that might benefit local communities, things like that. I think we should just take a broader perspective when we're comparing these different approaches.
Am I allowed to quickly say something? No, it was already my turn, because I actually really liked Romany's point. And if you look at actually the climate scenarios that I was talking about before, you actually have quite a spectrum of ways how you could actually reach the Paris goals. And it's actually not up to us scientists to say that this pathway is superior to the other. Our job is really to provide the whole spectrum, and then to let society decide which pathway they want to go down on. And it may very well not be the least cost one. It could be that society accepts substantially higher costs if they can safeguard other things than carbon as well, right? So maybe that's also something that we should definitely not lose out of sight, even if we're in the economic session.
Yeah, now might be a good time to talk to bring in considerations of environmental justice, human rights, and equity here, because one could imagine a certain so-called low-cost pathway for carbon utilization, for carbon deployment, but maybe it's only low cost because there's some externality, there's some brutal externality as part of that process, that if that were covered, if that were internalized in that process, it would be higher cost. So related to that, I'm curious, how do these kinds of considerations play into all of your work? When you're constructing these models or doing a legal analysis or whatever it might be, doing a policy analysis, how are you thinking about and centering these kinds of issues of environmental justice, of historic harms, and trying to repair for those, of ensuring that human rights are protected moving forward? I'm just curious to hear how you all kind of think about that, and maybe how you think about particular trade-offs and how we should really go about managing those trade-offs, and how we can instill good governance mechanisms to handle that. I know it's a lot, but at once, but curious to hear what y'all think.
It's a really good question, and I think it's a really important point, because we really want to make sure that when we're deploying these what are meant to be solutions, we're not just sort of further burdening or further disadvantaging already disadvantaged communities, of which there are many in the climate space. So, from my perspective, when I'm thinking about and when I'm researching sort of legal frameworks for these different approaches and thinking about what a model legal framework would look like, it's really thinking about ways to build in appropriate safeguards so that you don't overly constrain or restrict the development and deployment of these technologies, but at the same time, you're ensuring that they're developed and deployed in a way that minimizes adverse environmental impacts, minimizes adverse effects on communities, particularly low income and vulnerable communities, but also society more generally, because having those sorts of safeguards in place is really, I think, essential to ensure sort of for want of a better phrase, the social support that we're going to need to actually get these things into the real world.
Yeah, so maybe I can jump in too, and what Romany was just saying is also close to what I had in mind when I was talking about the accompanying governance architecture that would accompany any sort of CO2 pricing policy beforehand. But what CO2 pricing would also mean is that countries or groups or anyone who could provide carbon removal services would also receive some revenue, and that is also sort of an entry point for equity issues. So we should also think about how we can design incentive schemes fairly so that people can also benefit from the service that they are supposed to provide.
Absolutely. So I think this question of environmental justice is really going to be key for the mass deployment of negative emissions technologies. And this comes into a few different ways. The best places to build negative emissions technologies will probably be locations that have very cheap, or at least for direct air capture, very cheap electricity and nearby sequestration reservoirs. And those locations are pretty, there are a few in the world, and of course there are people who live there. And it's going to be critical if we, if we were doing like a big optimization model where you have an engineering central planner who makes all the decisions. Of course we put the stuff there, but as Sabine said, we want to make sure that, well, do the people who live there want these things there? Do they benefit from this? Do they understand what it is that this technology is? Are there any risks involved? What are the mitigation measures that can be in place? Do they get jobs in those places? Of course, there will be jobs associated with carbon capture and sequestration, although I haven't seen firm estimates on exactly what those will be. And I think there's been some really important work in this area done by Gabrielle Wong-Perotti, who is of Stanford University, during her PhD thesis on public acceptance of sequestration. Because it's something that on the face of it, I think sequestration will probably be the biggest public acceptance issue, because it's something that there are some risks associated with it. I think that they're quite, if it's managed well, I think it's very manageable. But at the same time, if that carbon dioxide were to come up very rapidly, which for most types of sequestration is super unlikely, it could pose a health hazard. And of course, if the people in the local area are not benefiting in any way from a local project, they probably wouldn't want to accept that risk. So as Sabine says, making sure that, that first off, that any risks are mitigated to the maximum extent possible. Secondly, that they're really communicated. And thirdly, that there's this partnership and stakeholder engagement, I think is going to be absolutely key.
Thank you all very much for sharing those points. It's a very important discussion, so we don't reproduce harmful and damaging industrial systems and so forth. So so thank you all for the wide-ranging panel discussion. We will now move into the audience engagement portion of our panel. So if anyone would like to temporarily join the panel to ask a question, to have a short discussion or back and forth with the panelists, please try to share your video and audio. You should see a button, maybe in the upper right, and we will accept you. Oh, hi, Neil. Neil's here to help out with that process. And yeah, and if nobody wants to share and ask, we can begin going through the chat, asking other questions there. So I'll give you a minute to maybe figure out that. And if no one wants to, I will look for a question from the chat to ask.
I'll take a little bit of moderator privilege here. I've been lurking in the background. Hi, everyone. I'm Neil Blair with AirMiners. Thanks for your thoughts today. I really appreciate it. Romany, I had a question specifically for you. Right in the very beginning, you mentioned, kind of the potential legal issues that can come up. And I know we have a lot of early stage companies and folks who are thinking about getting involved, sort of as a startup and in that type of model. Can you think of any early stage kind of legal regulatory due diligence steps that folks like these could take? That, I mean, these are people who are, potentially just pulling something off of a lab bench and trying to turn it into a product. They've got a lot of demands on their time. They're looking for financing and everything else. But my gut says maybe there's something in there, a few early steps that you could take that would save you a lot of effort in the future if you were one of these people starting one of these companies. So just curious if you could give, I know it's not free legal advice, but just like, hey, here's where a couple of the, early steps you could take might really serve you in the future.
Yeah, I think the most important thing, and this is sort of before the point that you're talking about, but the most important thing people can do is, as they're developing research projects, to actually look at these things, include a social science component to that, which would include legal, but would include social acceptability and other issues as well. Because if you can include that in the design of the project up front, I think that's really valuable to inform sort of the design of the technologies going forward. If you're sort of beyond that point and you're looking at, opportunities for commercialization, obviously, and I don't work in private practice, so I have no benefit from saying this, but, if you have the funds, you should engage a lawyer early on, just so that you know what you're dealing with, because they're all different for all the legal issues are all different for all the different approaches, and for depending on where your sort of where you're engaging in them. So it's really valuable, I think, having that input. If you don't have the funding for that, then, reach out to a legal academic that works in the space. We're usually pretty happy to talk to people. I do that all the time. So I hope I don't get flooded with requests now, but yeah, certainly, having some sort of legal input into your project can be really valuable.
Well, there's only 66 people in the group here watching right now, according to what I can see. And I think only like 64 of them are starting companies. So it's fine. It's totally, I'm sure you won't get flooded. All right, so for folks who want to ask questions, I see a ton of really great questions. We can moderate these and bring these in. But yeah, it looks like some of you are figuring out here that you just, oh, we had someone for a moment there. Are they joining? Great. Yeah, you just hit that share audio and video button in your upper right, like Thomas is showing us, being a great example. And I'm going to leave at this point, but we can pull those questions in from all the comments. I'll scroll through, and if anyone's having AV challenges, I'll go ahead and pull those off, join back in, and sort of be the surrogate asker for them. So.
Great, thanks. Hi, Evan, how you doing again? And Grant, yeah, bearded brothers here today. I just had a general question about social justice and environmental justice. I have a real estate background, commercial real estate background. We're looking at large land-based solutions, but I'm also looking at some projects in urban and industrial areas. And I kind of wanted the group's thoughts on centralized projects, like big focused developments versus decentralized projects. Like an example, which is total environmental and social problem, is urban heat islands in cities, in the low income areas, and talking to investors about that, or how we would manage the projects. All those spread out over the city, or they're small parcels, and to try and combine those. So I'm just wondering what the group's thoughts are on assembling those kind of projects with carbon projects as well, for the social and environmental benefit, without getting the projects too complicated. Too many properties, too many locations, too much sensing, too much lost opportunity cost, every time you add a parcel to a project.
So I think it really depends on the technology in question. For some technologies, like the high temperature direct air capture system from Carbon Engineering, this is operating at 900 degrees Celsius. To get to scale, they have to get to, well, the systems they're initially remodeling and now are building are about a million tons of carbon dioxide per year. So these are big projects. And there are definitely advantages to that, even for more modular technologies, like Climeworks technology can be produced at a much smaller scale. But if the goal is direct air capture with sequestration, so directly going into the ground, well, then you have to have wells in some sort of a sequestration formation, either a couple different types of formations, and those are all going to benefit from economies of scale. And a really nice thing about direct air capture is that the atmosphere is well mixed, so you can pull carbon dioxide out anywhere you want, and that means it makes it easier to skirt a lot of permitting issues and things like that if you want to build in, say, a more built-up area.
Yeah, I don't have much to add. I would just say, I think when you're thinking about sort of the social implications of what you're talking about, it's important to recognize that there can be really, even within a relatively constrained area, there can be sort of sub-communities within that area can have very different views and perceptions of different approaches. And so I think that there is a risk when you try to combine multiple sort of low income or vulnerable communities from different places, they all have different things that they're concerned about. And so I think there's a risk that you sort of engage in a public consultation or public engagement process that is less effective and that's less useful in sort of mitigating and managing potential opposition. So I think that's just something to be mindful, that you're not sort of assuming that all disadvantaged communities, even within a particular city, have the same interests and the same concerns.
Sure.
And maybe just to add to the previous speakers, I wasn't also sure what you had in mind in terms of technologies, but you were saying that you were looking into land-based things as well, and often what I have learned is that sometimes the co-benefits might actually even be higher than the carbon benefit, and so in that sense, that might actually be an argument to consider also more decentralized approaches, because you might actually be quicker that way to scale things in the end.
So Sabine, how would you define that, or decentralization with co-benefits? Can you use an example?
Yeah, so for instance, I wasn't sure what you were talking about, but you mentioned, for instance, the urban heat island effect. And so I was thinking that maybe you're talking about adaptation options, so that you would have, for instance, green areas to alleviate the urban heat island effect, and that might actually be more valuable for the community on the ground than actually the carbon that gets stored in that.
Right.
But if you immediately streamline this into that, then you might actually collect a lot of projects that might look more decentralized and get them off the ground more quickly by having a common streamlining of the two objectives. So that was what I had in mind, but maybe I also misunderstood what you what you were aiming at.
That's great. Yeah, appreciate that. Okay, thank you.
Thank you, Thomas. Thank you for joining us. So there's a question that I found in the chat that people here may be interested in answering. So Peter asks, so he says at Romany, but I think everyone be able to answer this too. How would you assess the EU's current efforts to come up with an EU-wide comprehensive CDR certification framework? This could maybe help provide a basis for a CDR-specific legal framework as well. So I personally haven't heard about this EU-wide comprehensive certification. So yeah, are there any comments on that from the panel?
I'm not particularly familiar with it. I can't comment on it in detail. Sabine, maybe you're better placed.
Yeah, so it's something that they're developing at the European Commission right now, but it's not yet finalized. But it's called the Carbon Removal Certification Mechanism, and the main idea is, of course, to be able to certify a removed ton of CO2, so that you can then build the appropriate incentive mechanisms around it. So maybe even though this is not a part of the discussion yet, maybe even to sort of integrate it into the emissions trading framework, for instance, over the longer term. So. But yeah, I mean, with respect to the question, I could imagine that could also help providing a basis for a legal framework as well. But yeah, as I said, it's currently something that is being developed, and nothing, I think, has been cast in stone yet. But I think it's the first time that there is such a move, and that's definitely a good sign, because people are thinking how to organize legal and policy issues, and that's definitely a very much needed first step.
Fortunately, I'll have to admit ignorance on this one. I've been living in the methane emissions world for much of the past 2 years, which has been amazing. But this is something that I will look into.
But there could also be methane removal.
So another question came up from Ben in the chat. As this is a panel on the economics of CDR, who is the we, in quotes, that should pay those costs? So when we talk about paying for these things, whom are we really talking about? You know, if we're talking about government deployment, should, like, I guess in that case, it would be taxpayers of a given country paying for it. Does that make sense? Is it just? Yeah, kind of who is covering these costs and all these different possible scenarios, and who should be, in your opinion, maybe covering these costs?
Well, in a world where sort of this hypothetical scenario that I was having in the beginning, where we would have global carbon pricing, in that case, in a net zero world, every additional ton of CO2 that's still being emitted would sort of pay for its own removal, right? The revenues from that would actually pay for the removal of the same ton. Of course, if we are in a net negative world where we withdraw more CO2 than we're emitting, then of course there needs to be another revenue source, and that would probably come from other sources, for example, taxpayers. And that's then, of course, also a societal decision, right? Do we actually want to be in a situation where we have to go net negative? and what do we pay that from? But as I said also in the beginning, when we were talking about the different pathways to reach the Paris goals, it's a societal decision which pathway we want to be on, and society may well decide that they don't want certain technologies or certain pathways, and there are a couple of pathways, for instance, where you remove relatively little CO2. I mean, relatively little is still at gigaton scale, but where you remove less than in those scenarios where you have a lot of like double-digit gigaton CO2 removals per year, and that means then more reductions, for instance, on the demand side. And that's something that people have to decide on, right? I mean, that's actually current. We're living a little bit through something like that, with lockdowns, reduced mobility, change consumption patterns, and so on. So there has been quite some change to lifestyles, and and that's also an acceptance issue, right? I'm not saying that this pathway is without challenges. Probably it's equally challenging than to ramp up technologies within a very short time window.
I agree with Sabine that it is sort of a social choice. The problem that we have, of course, is that the society that's making the choice is not necessarily the one that's going to pay the cost, because of this sort of, or at least some proportion of the cost, because of this sort of temporal dimension. So I think that presents a real challenge. You know, I think ultimately, sort of practically speaking, it will ultimately fall to taxpayers to, you know, make up any shortfall in the net negative scenarios that Sabine mentioned. You know, there have been moves at various times to hold, within the sort of legal community, to hold sort of particularly climate harmful industries, fossil fuel production companies and others, accountable for their contribution to climate change. Some cases brought here in the US by local governments in particular, seeking to have fossil fuel companies sort of pay for some of the costs they incur in adapting to climate change. So building seawalls and things like that. You can imagine a similar body of litigation requesting that fossil fuel companies or others that have contributed to past emissions pay for future carbon removal. So far, certainly here in the US, that litigation has been largely unsuccessful, but you know, perhaps things will change in the future, and perhaps things are different in other places.
So who's the we? This is, I mean, this is the, as an academic who does not have tenure, I'll limit my responses somewhat, but I'll limit my responses to fleshing out this question. As in a lot of our, like the types of models that I work with, we have, there are society has resources and can allocate resources in different ways, and there are costs, and we compare the net costs and the net benefits in society. Of course, society is composed of people, and its resources are not distributed evenly within countries, across countries, and so there are enormous questions about who, so taxpayers, if taxpayers pay for carbon dioxide removal, pay for greenhouse gas mitigation. I don't really see a way around significant government-led action on climate change. But then that raises the question of which taxpayers, and which countries' taxpayers. And I will refrain for the next at least 6 years from giving more particular answers.
So I think thank you for sharing all of those. And so this idea of maybe having companies pay in some respects, it's come up in the comments a couple times, maybe several of you have alluded to it. And there's a comment that just came in from Kate. Let's company pulls CO2 from a polluting company's emissions and produces a product for sale. From a carbon accounting and economic standpoint, where should the carbon negativity, or I guess the credit for that carbon negativity, be given? The polluter who is polluting less, the consumer of the product? Is there a way to reward both parties while not double counting this emission, this negative emission? So are there any thoughts on that? It's a somewhat related point to what we were talking about.
I might not properly understand, but I'm not even sure whether there is carbon negativity, because if you pulled CO2 from a polluting company, say whatever, a coal power plant, or then like turns that into a product, even if the CO2 is stored away in that product for forever, which it might not be, I think nothing has been really removed from the atmosphere. I mean, that would work if you had pulled it from the atmosphere, but not from a company. Or maybe I didn't understand the example, and we need Evan to.
Oh yes. So it seems to me like there are a couple ways to interpret this question. One is if it's I wouldn't call it carbon dioxide removal if it's just directly capturing tailpipe emissions from a coal plant or something like that. And exactly as Sabine said, if carbon capture from point sources may be a thing we want to do, but it's certainly not carbon negative. At best, it's zero emissions. And there are many different sort of schemes in place for a company for allocation of how those emission reductions are done. But that said, there just aren't that many post-combustion carbon capture projects happening. Hopefully, we'll see things like cement manufacturing. But then the second question is if a company does carbon dioxide removal from the atmosphere, which is the more generally how the term carbon dioxide removal is used. Well, in that case, we don't know whose carbon dioxide they're pulling out of the atmosphere. They're just pulling carbon dioxide out of the atmosphere. And so there's very little risk of a company that emitted getting undue credit there.
But I think what definitely the question points to is that whole problem area around a CO2 utilization, and that it's very difficult to do the accounting right. I mean, because one industry might actually be carbon neutral by utilizing CO2, but what happens then if their product is used and the carbon is released again, or you need a lot of non-decarbonized energy, or you get the CO2 not from the atmosphere but from fossil sources. So I think this sort of cross sector life cycle analysis is something that we cannot really cannot really neglect. Sorry, I didn't want to kick anybody out. Somebody came up and I was blabbering on.
Yeah, that was Ardea. She came on but left, I suppose. But Ardea, if you still have a question, you can come back up. I will say too, in terms of the allocation in a life cycle assessment, there's something called system boundary expansion. That, like, if you're capturing CO2 from a cement factory or something, and then you're utilizing it in, say, some kind of place. Oh, here's Ardea back. You're utilizing it in a product where it is permanently sequestered. It would be double counting if the cement plant said, oh, we reduced this carbon, and then the other the place actually utilizing the carbon said, oh, we're sequestering it as well. But from a life cycle assessment practitioner's view, they might assess both of those at the same time. They'll like it says, they'll expand the system boundary, and they'll look at kind of both production processes, and they'll look at, if we don't do the carbon capture and utilization, what are the total emissions from this combined system? And if we do it, also then what are the total emissions? Then you'll just compare those different things. But in terms of credit, yeah, that's a trickier thing when you're talking about. You just want to ensure that things aren't being double counted, and that there aren't those kinds of claims going on, because that would be bad. It would be double counting. Ardea, welcome.
Hi. Good question, Kate. Grant was just looking over some of my carbon accounting stuff that I'm doing, and for my company. So my company is Polima, and we're using hemp byproduct that would otherwise be burned to press it into a wood alternative for tables and chairs. And I've been trying to figure out the best way to market that as well, because the way we see it is that it's almost like point source capture, because we're preventing that carbon that the plant has captured from becoming CO2. And so I'm wondering how
you guys would market that, because to me it's totally different, because we're using a byproduct that is about to, if we don't come in, it's about to create emissions, but we're preventing that. So how would you talk about that?
I would call that mitigation, because you're actually substituting something that has a bigger carbon footprint. So it should be eligible for any mitigation payment, be it in now a permit in terms of emissions trading, or be it a tax break, whatever system you're in. But I mean, it's not a removal from the atmosphere, but I mean, mitigation is also important. We pointed that out very strongly. And if you can avoid emissions by it that would otherwise have happened, I think that's a valuable thing.
Very helpful. Thank you. Anyone else?
So this, yeah, there are a lot of moving parts in this question, because absolutely, by preventing it from being burned, you're preventing emissions now. At the same time, at the end of life of this product, depending on how it's disposed of, it eventually will decompose and become carbon dioxide in the atmosphere, at least some of it.
I want it into biochar. Like, I want the end of life to be biochar.
Okay. Yeah. Well, in that case, then that sounds like something to highlight. And another aspect would be in the combustion of hemp. Depending on how it's combusted, there could be pretty significant particulate matter emissions and other criteria pollutants that could have human health impacts that are not directly related to climate change, but are something that you could quantify and make a further case.
Cool. Yeah, I didn't get the char part. Sorry.
Yeah. Because then that would be adding what, 1,000 years of permanence?
Okay, I think we are coming to the end of our panel. We are near the top of the hour, so we can conclude today with our discussion about burning hemp. We're having some fun. And so there are two other panels that are starting very shortly. So to everyone in the audience, please, we maybe want to take some time to take a bio break, but yeah, you can click on panel sessions on the left and look for other two panels that are going on. Neil, you're pointing to the right on my computer.
Dang it.
Yeah. Okay.
So yeah, it was the right way on mine.
Yeah, right. So thank you very much to all of our panelists. Very, very great discussion. It was fun. And yeah, thanks again. I hope everybody enjoyed and found it useful.
Yeah, thanks for having me. It was fun.
Thank you.